Hello students, welcome to Learner's Planet, Theory Session 5 of Metals and Non-Metals. In this session, we will be discussing chemical properties of non-metals. So let's move to the chemical property of non-metal. Here it's children, the ionization. Now what do you mean by ionization? It is that how they are forming ions. Now these metals children, as we studied, they ionize by losing electrons. But non-metals, they always ionize by gaining electrons. Now in this case, so if they are gaining electrons, what will be the charge of their ions? They will form negative ions. Like your chlorine, this is for children, Cl2. So how many electrons should it accept? It should accept 2 electrons. So I'll write this equation as this Cl2. How many electrons should it accept? It should accept 2 electrons, right? So I am writing Cl2. I can't write Cl because chlorine is a diatomic gas. Got my point? Now this will accept how many electrons? This will accept 2 electrons, and what is it going to form? It will form 2 Cl minus ions. So what type of this ion is? This is a chloride ion or a negative ion. So as these non-metals are forming negative ions, they are called as what? Electronegative elements. We'll take the example of sulfur also. Sulfur, how many electrons are there in the outermost or the valence shell of sulfur? So sulfur, let's take out. What is its atomic number, children? Its atomic number is 16. Now let's arrange these electrons or its electronic configuration. It would be 2, 8 and 6. So how many electrons it requires to complete its octet? It is requiring only 2 electrons. So what does sulfur will do? Sulfur will accept 2 electrons and will form what? Sulfide ion. Likewise, if I take nitrogen, so your nitrogen also exists as N2 gas. So how many electrons it should accept? Now what is the atomic number of nitrogen? The atomic number of nitrogen is 15. How can we arrange these electrons? It can be like 2, 8 and 5. So how many electrons it requires to complete its octet? It requires only 3 electrons. Now as nitrogen is existing as a diatomic molecule, so how many electrons it should accept? It should accept here 6 electrons and it should form 2 N3 minus ion. Clear, children? So it would be what? 2 N3 minus. It would be like this. Now what is the name of this N3 minus ion? It is nitride ion. So there are very few compounds in which nitrogen is present as nitride ion, like hydrazide N3H, that is the nitrogen has got -3 valency. Now let's move to its next chemical property, that is, we are here with the type of compounds. So what type of compounds these non-metals are forming? Metals are forming what type of compounds? They are forming ionic compounds, whereas the non-metals, they are forming both ionic and covalent compounds. Now what are ionic compounds? How are ionic compounds formed? We discussed this in the session of metals when I was discussing the chemical properties of metals. How are these ionic compounds formed? Ionic compounds. What type of bonds they have, children? They have ionic bonds. Now how this ionic bond is formed? This is formed by transfer of electrons from atom of one element, or we can write atom of the element, because it is not necessary that there are two atoms or two types of elements. Yeah, there are two types of elements. So atom of one element to the atom of other element. Now in this case what happens, that the element which gives electron is what? Is electropositive, and the element which accepts electron is what? It is electronegative. Now there is transfer of electrons. Can you suggest me any example? Like NaCl, it is an ionic compound. KCl is an ionic compound. Calcium chloride is an ionic compound. Magnesium chloride is an ionic compound. So in these things, what are we seeing, children? We are seeing that the one is metal, the other is non-metal. Again a metal and a non-metal. Now coming to the non-metals, that is what type of compounds they are forming. They can form both ionic compounds as well as the covalent compounds. Now, I would first like to tell you what are covalent compounds. What are these? These are the compounds which are having covalent bonds between their atoms. Now, what do you mean by a covalent bond? That covalent bond is formed by sharing of electrons between atoms of elements, are called covalent compounds or are called covalent bonds. So it's necessary that the covalent compounds have got covalent bonds in them. So I would like to discuss one of the chemicals or any of the compound, like your let's take this carbon dioxide only, or let's take nitrogen or oxygen. Now in this case, children, what is this? If I take the case of oxygen, what is the atomic number of oxygen? It is 8. So how many electrons are there in the valence shell? It is, children, 2 and 6. So how many electrons in the valence shell? 6 electrons. So how many electrons it requires to complete its octet? There are 6 electrons here. 1, 2, 3, 4, 5 and 6. How many electrons it requires to complete its octet? So if there is plus 2 electron, its octet will be complete. So these can gain 2 electrons, but there are very few cases where oxygen is forming the ionic bond. Oxygen forms the covalent bond. Like if I am taking this thing, oxygen molecule. So oxygen molecule, how it would be formed? Say this is your one oxygen atom, this is another oxygen atom. So what they will do, children? They will share 2 electrons. Now when they are sharing 2 electrons, this electron will be counted with both the oxygen atoms. This is oxygen first atom and this is oxygen second atom. And this is represented as oxygen double bond oxygen. So that the octet of both the oxygen atoms is complete. And both of them are having 8 electrons in their valence shell. N2 is also forming a covalent bond. If I am forming H2O, so how it will be formed? There is, let's form H2O, there is also a covalent bond here. Now oxygen, it requires how many electrons to complete its octet? It requires 2 electrons to complete its octet. So, and hydrogen, it can share 1 electron. Hydrogen, the number of electrons in the valence shell. It is 1. How can it complete its duet? By sharing one electron, right? It can lose also, but it will lose it to a highly electronegative element. Now, what it can do is it can accept. Oxygen is not going to give, hydrogen is not going to give. What they will do? They will share their electrons. See, this is your oxygen atom. This is your hydrogen atom, and this is again your hydrogen atom. Okay, so now these are sharing electrons, one electron of hydrogen, one of oxygen. Now I can just change the color and show you. So this is the electron of hydrogen. This is again the electron of the second hydrogen. So I can write here electron of hydrogen, and these two are the electrons of oxygen. Now in this manner, what has happened? The octet of oxygen is complete. It had already 6 electrons. It shared 2 electrons. The duet of hydrogens are complete. Now your structure of water becomes like it is a V-shaped molecule. I would not go to the structures now. We're dealing with the structures in your 11th sessions. Now their water molecule, this has got a structure like this. Now both the octets and the duets are complete. So children, covalent bond is formed by sharing of electrons. Now let's move to the properties. The examples: carbon dioxide, water and ammonia. There are many more compounds like hydrogen chloride, like ammonium hydroxide, like a sulfuric acid. All are what? Covalent compounds, because they are formed by non-metals. Now let's move to the next property. Chemical properties of non-metals. Deposition during electrolysis. They are always deposited at anode, the positive electrode. We know that non-metals are forming what type of ions, children? Non-metals, they are forming electronegative, or we can say negative ions. So where they should be deposited? They should be deposited on the positive electrode. In the electrolytic cell or during electrolysis. Now its next property is redox reaction. Redox means the reaction where oxidation and reduction occurs simultaneously. That is what? That is a redox reaction. What they do there? They gain electrons and hence get reduced. Now because they are reduced, what they will do? They will oxidize others. Like they are redox agents. That is, these are oxidizing agents. These are accepting electrons, and what they are doing is they are oxidizing others. Now we know that what is oxidation? Just to revise, I am telling you, oxidation is loss of electrons. And reduction. What is reduction, children? It is gain of electrons. Now if I am writing a simple equation of say Na plus of Cl gives you what? I am writing this equation. Na plus Cl2, 2Na plus Cl2 gives here what? 2NaCl. So it is 2NaCl. What is it doing? Sodium, the electrons are transferred from sodium to chlorine, and this chlorine is accepting the electron. It means from where the electron has lost? From sodium. Which is oxidized? Sodium. Which has gained electrons? chlorine, which is reduced chlorine. So what are these serving as? These are serving as oxidizing agents. Now there is atomicity. What do you mean by atomicity? Atomicity is the number of atoms present in its molecule. So these can be mono, di, tri or polyatomic. Mono means it's helium, diatomic, nitrogen, even ozone can come in polyatomic, this is triatomic. After diatomic all are polyatomics. And one more, there is an example, that is S8, selenium. How many, or sulfur? Sulfur is S8. It is octatomic or again polyatomic. Or selenium is again polyatomic. So these are the elements which occur as polyatomics. Now moving to the next chemical property of these compounds, that is reaction of nonmetals with oxygen. Now let's see how these react with the different reactants or the elements or the compounds. Now nonmetals react with oxygen to form acidic oxides or neutral oxides. Do you remember what type of oxides were formed by metals? They were basic oxides. Now whereas these non-metals, they are forming what type of oxides? Acidic oxides. The oxides of non-metals dissolve in water to form acids. Let's take up some of the examples. Like when carbon burns in air, it reacts with oxygen of air, forming an acidic oxide called as carbon dioxide. That is carbon plus of lots of air, and it will give you what type of oxide? Carbon dioxide. Now children, this is also a covalent compound. The structure of carbon dioxide is carbon in the center with two bonds, that is the double bond, and it is bonded to what? It is bonded to oxygen here. These are what type of bonds? These are your covalent bonds. Okay children, so these are covalent bonds. Now let's take up few more oxides. That is your in the presence of insufficient oxygen, that is when oxygen is less, carbon forms carbon monoxide. That is 2 carbon plus less amount of oxygen, or there is insufficient oxygen, and it would form what? Carbon monoxide. There is another non-metal here, that is sulfur. When sulfur is burnt in air, it reacts with the oxygen of air, forming an acidic oxide that is called as sulfur dioxide. So this is sulfur dioxide. Now all these oxides or all the compounds of non-metals are what children? They are covalent in nature. Now let's see how these oxides react with water. Carbon dioxide dissolves in water, forming an acid called carbonic acid. That is, carbon dioxide plus water gives carbonic acid. How does carbonic acid dissociates? Why is it an acid? It is an acid because it dissociates in water and gives you what children? It is giving us H plus ions. Right? So this is H2CO3, and it will dissociate and form what? It will form 2 H plus ions plus of CO3 2 minus ions. That is why it is an acid. Now there is another compound, that is sulfur dioxide. This dissolves in water and gives what? Sulfurous acid. Now children, this is sulfurous acid it is forming. Do you know what is sulfuric acid? What is the formula of sulfuric acid? It is H2SO4. And what is this forming? Sulfurous acid. Now how this will behave? This sulfurous acid H2SO4, how it will cleave children? This will cleave forming what? It will form H plus ions plus of SO3 2 minus ions. Now it is again giving what type of ions in solution? It is giving hydrogen ions. So what type of compound it is? It is an acidic compound, right? So these non-metals, they are forming acidic oxides, and children, they are also forming neutral oxides. Neutral oxides like, I'll write here, neutral oxide. Neutral oxide like carbon monoxide, that is, it is neither acidic nor basic. It will not change the color of litmus paper. NO, nitrogen monoxide, it is again a neutral oxide. Right children? So these are forming neutral as well as acidic. But children, these are not forming amphoteric oxides. You should remember this. This N2O is also a neutral oxide. So these compounds, when they are dipped in litmus solution or when litmus solution or when they react with litmus solution, they do not change the color. Whereas your NO2, that is nitrogen dioxide, this reacts with water children, and what is it going to form here? It will form nitrous acid. It will be the formula of it, HNO2, or it can form HNO3. It forms HNO2 basically, and this is what? Nitrous acid. Your NO3, when dissolved in H2O, it gives HNO3. So what type of oxides these are children? These are acidic oxides. This is nitrous. The above one, that is HNO2, is nitrous and HNO3 is nitric. Likewise, your phosphorus, that is P2O5, phosphorus pentoxide, when it is treated with water, they form what children? They form their respective acids. So it will form its acid, that is H3PO4. What is it children? This is phosphoric acid. So I would like to say, or the conclusion of these is that the non-metals, they are forming acidic and neutral oxides. Now moving to the next reaction or the chemical property, reaction of non-metals with hydrogen. How they are going to react with hydrogen? This hydrogen forms hydrides with only few metals, that is, which are very reactive, like sodium, like potassium and calcium. Okay, it is not forming hydride with other metals. And in this case, it is forming hydride because in hydrides, what type of bond is present? In hydrides of non-metals, what type of bond is present children? In hydrides of non-metals, covalent bonds are there, right? Covalent bonds are present between the atoms. Now in this case, what all are the hydrides here? N2, that is nitrogen, reacts with hydrogen, H2, and it forms what? Ammonia. NH3, this is again a covalent hydride. H2 reacts with, I can draw the structure of ammonia like this. This is the lone pair of electron, and this is one hydrogen, the second hydrogen, and the third hydrogen. Hydrogen reacts with chlorine, forming what? Hydrochloric acid. Hydrogen reacts with oxygen, forming what? Water. Now this hydride is again a neutral hydride. Now this is about the reaction of nonmetals with hydrogen. Likewise, phosphorus reacts with hydrogen, forming phosphine, that is PH3. Sulfur reacts with hydrogen, forming what? Sulfur dioxide. Sulfur reacts with hydrogen, forming hydrogen sulfide. That is H2 plus S gives H2S. Now let's move to the next reaction, that is reaction of nonmetals with water. Nonmetals do not react with water. Why? Because nonmetals form negative ions by accepting electrons. Clear? I have already told you. Chlorine is forming chloride ion, bromine is forming bromide ion, sulfur is forming sulfide ion, nitrogen is forming nitride ion. So all the nonmetals are forming negative ions by accepting electrons. Now they cannot give electrons to reduce hydrogen ions of water and convert them into hydrogen gas. Like if I am taking this Cl2, or let me take this phosphorus P4 plus H2O. Now what these metals do, children? Metals with water, what type of reaction they do? They undergo? They form their respective hydroxides or oxides and release what? Hydrogen gas. Now if there is a reaction like this, if you are getting a reaction like this, that is P2O5 plus of hydrogen gas. Now this reaction is wrong, children. Why this is wrong? Because phosphorus P4 is what? Is a non-metal. So can it give electron? It cannot give electrons. Okay. Now for the release of hydrogen gas, your water here dissociates and it forms what? H plus of OH minus ions. Now for this hydrogen to be released out as H2 gas, what it requires? It requires 2 electrons. Now from where these 2 electrons will come? Phosphorus is a non-metal. It is not going to give any electron. From where these 2 electrons are coming? It is not coming. So hydrogen gas will not evolve. So this is a very, very important concept. You should keep this in mind, that nonmetals form negative ions by accepting electrons, so they cannot reduce hydrogen ions to hydrogen gas. And any such sort of reaction, taking any nonmetal, phosphorus, nitrogen, or your boron, or this thing, any nonmetal you can take, carbon also, this doesn't react with water. Nitrogen is not reacting with water. Nitrogen is insoluble in water. Oxygen is also not reacting with water. So this is a very, very important concept, children, and you should keep this thing in mind. Now I'm concluding this session, and in the next session we will discuss few more properties of non-metals and also about the extraction of metals.